Welcome to Ask and Learn.
This is the answer to Chapter 20, problem number 57 from the Smith Organic Chemistry textbook. And in this problem, we're asked to draw a stepwise mechanism for the conversion of this dilactone to a tetrol, or a molecule with 4 alcohols on it. And so basically, this is going to be delivery of a hydride 4 times. So we're going to draw the mechanism for the right side, and then the exact same mechanism is going to repeat for the left side. So the first thing that's going to happen is delivery of the hydride as a nucleophile to the electrophilic carbonyl carbon. And so the result of that first step is going to be something like this. So this part of the molecule is not affected by that first step. And then the other ring will look like this. So we have our oxygen there. The hydride has added here. And so this oxygen is now going to have 3 lone pairs, and I forgot an arrow here. I apologize. So that is going to happen as well. So now it's more obvious. This oxygen has 3 lone pairs and a negative charge. And so the next thing that can happen is one of those lone pairs can add back in and reform that double bond. And the bond between the carbon and this other oxygen will break. And so when that happens, now our ring is no longer a ring on this side. So we're back to having carbonyl here. So we have an aldehyde now. And then here we have an alkoxide. So there's our alkoxide and our aldehyde. And then basically, we're using an excess of lithium aluminum hydride. And so sort of the same thing can happen again. So another aluminum hydride molecule can come along and can again be delivered to the carbonyl carbon. And so now we have an alkoxide there as well. So now we have 2 alkoxides here. Okay. So now we're just going to do the exact same thing again with the other side. And so another aluminum hydride can come. The hydride can be delivered to this carbonyl this time. And the mechanism is going to be exactly the same. Okay, and so once again, we'll see one of the lone pairs add back in to reform that carbonyl. we'll see the bond between the carbon and the other oxygen break, and those electrons will revert to the oxygen. So now we have 3 alkoxides. Both rings have been opened, and so we have 3 alkoxides and an aldehyde. So here's our aldehyde. Again, just as in the first part of this mechanism, one more hydride will be delivered, and that will give us our final reduction. So all 3 of these are alkoxides. And then one more hydride can come along and be delivered to this carbonyl. And just as we've seen the other 3 times in this mechanism, those electrons will kick up to the oxygen. So now we have all 4 of our oxygens as alkoxides. And rather than draw this 4 times, I'm just going to draw it once. So now when we work the reaction up with some water, each of the alkoxides will be protonated. So I'll just draw it once, as I said, but understand here I'll put a times 4. So this is happening to all 4 alkoxides simultaneously. And so the end result is our final product. With 4 alcohols. Okay, and so there we go. That's the stepwise mechanism for this reaction. Again, it's just hydride delivery 4 times. So the hydride's delivered to the lactone. The alkoxide that's formed there closes back down, which opens the lactone ring. And then the hydride is delivered again to that newly formed aldehyde to get us to the double alkoxide. And then we repeat those exact same steps on the other ring. And then protonation of all 4 of those alkoxides that we make gives us our final product. And that's the answer to chapter 20, problem number 57.